Good morning, dear students. Today we are going to start a new chapter, that is inverse trigonometric functions, ITF. And inverse of function we have already studied that inverse of function that we know that corresponding to every bijection or bijective function, that is nothing but 1 1 and onto function, and that is defined as function f from a to b. There exists a bijection, again another bijection we will get, that is g from b to a, defined by, we have seen that it is, if that exists, then defined by g of y is equal to x if and only if f of x equal to y. The function this one, g from b to a, is called the inverse of the function f from a to b, and also it is denoted by f inverse. So these many things we have studied in the previous chapter, that is relations and functions. We have studied that how to find the inverse of a function. So thus we can say, does f of x equal to y, and that implies f, if we put f inverse on both the sides, we'll have f inverse of y equal to x, and if we'll again put f inverse to the both the side, we will get this thing. So we have also learned that f inverse of f of x is nothing but f inverse of f of x is nothing but f of x is y. So f inverse y, and what is f inverse y? We have seen this is nothing but x, where all x belongs to a, and if we consider f of f inverse of y, then this is nothing but f of f inverse of y. F inverse of y, we have seen this is nothing but x, so it will become f of x, and f of x is nothing but y for all y belongs to b. So these many things in the previous chapter we have seen, and before starting to ITF, that is inverse trigonometric functions, we'll have a glance to the trigonometric functions. Once you know very well the trigonometric functions, then only one can understand the inverse trigonometric functions. So let us consider this one, sine. Sine is a function from r to minus 1 comma 1, that is its value. Cos is a function and domain is r, and the range is minus 1 1. Tan is a function r, and we cannot put the value this one, that is we are subtracting from real number r, that is x, such that x is equal to 2n plus 1 into pi by 2. Why? Because we are getting at the angle pi by 2, we get infinity or not defined. That's why we are not considering this value. Except these values, everything is domain, and n belongs to, that is integer z, and that to r. So whatever value we are getting, that is also sec from r, and we cannot take value x such that x equal to 2n plus 1 pi by 2, where n belongs to integers, and you will get a range r, and definitely you cannot have -1 to 1. Already you have over here, so it is sorry, here, so you have this value. Okay, cosine, that is r, minus x such that x equal to n pi. Why n pi? Because at value of 0 degree, you'll be having that cosec is not defined. That's why we are eliminating these values where n belongs to integers, and the function goes to r minus -1 to 1. So we cannot take the value between -1 to 1. So we are deleting that value from this real number. So we'll get, then last but not the least, that is cot, and this is function. This function is from real number except x, that x is defined as equal to n pi, and belongs to real number z, and to real number. So whatever you are putting the values, you are getting the same thing, and these are nothing but domain of a function. This is range of a function. All the values whatever I have written over here, that is before this arrow, is domain of function, and these many values are range of functions. Similarly, here also it is domain of function, whereas these portions are range of a function. We have we know that trigonometric functions are periodic functions, therefore it is not possible to take the inverse of that. Therefore what we are doing is, to get the inverse of trigonometric functions, what we are doing is we are taking small portions over there, or we cut the portion particular thing. For example, if I take, this is a quadrant, this is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. So what we are considering is, for a sign we are considering this is positive up to pi by 2, and this is 270 degree, or 3 pi by 2. But what we are considering is, we are calculating these on the negative side, that's why it is minus pi by 2. So whatever we are going to calculate is, we are calculating from here to here only. So what I am getting is, for sine, tan, and cosine, these many have this value from minus pi by 2 to pi by 2, whereas in min phi, that depends on whether that function is defined on particular things or not, like cosine is not defined in these particular things. So we cannot define. So what we are doing is, we are eliminating this particular value, that is 0, on from here. So we'll get the cosine over there. Okay, so coming to the next point, the remaining three, that is cos, then we have cot, then we have secant. These many functions we are cutting from this to this point. That means this is 0, this is pi. So we are cutting these functions from 0 to pi, and we are cutting these functions from minus pi by 2 to pi by 2. That depends whether that function, a particular thing, like in 10, these two things are not included, this is excluded, and remaining portions, cosine and sine, these two can be included. So inverse of a sine function, we'll see. Inverse of a sine function, first one, inverse of sine function, f of x equal to sine x we can consider, and the domain of function and range of function we can consider. Domain, you can have domain as a real number over here, or better I say, you can put 0 to 2 pi, this is for our convenience, and the range whatever we are getting is minus 1 to 1. So what I am doing is I am cutting from minus pi by 2 to pi by 2, because of this is periodic, and periodic function cannot have that inverse of that particular thing. Why? Because this function is basically not a bijective function, it is many one and into function. This is basically periodic, and periodic because of this periodic, this function is many one and into, and what we need is we need 1 and onto, we need this. That's why to convert this function or to get the inverse of this function, what we are doing is we are selecting some particular thing, so that what we are doing is we are making this function 1 and onto, and because of that particular thing we will get the inverse of sine function. So basically this is what we are taking is from here to here, and definitely in this particular thing, in range, in domain, we are getting as minus 1 as a range, and whereas these two things will work as a domain function and as a range function for sine inverse x. This is sine inverse x. Let us consider, and this can also be written as ARC sine x. There are two notations. First one is sine inverse x, and another notation is whether we are writing this symbol or this symbol, both are the same. And one more thing, one should not misunderstand that sine inverse x and sine x to the power minus 1, these two things are not equal. This is nothing but 1 by sine x. In trigonometric functions we have studied that if I want to write sine x to the power 4, so easily I can write sine power 4x, but in the case of inverse it is not defined. That's why it is not equal. Both the terms are very different, and it is in positive sign we can use this one, but in negative sign we cannot use this one. So in sine inverse x, we can write sine inverse from -1 to 1 to minus pi by 2 to pi by 2. The function sine inverse is defined in between these two values. Okay, so let us draw the graph. So graph is like this. If I consider for sine, this is pi by 2, and the negative side will consider this as minus pi by 2. This is 1 and this is minus 1. So this is the graph of sine x, and sine inverse x will get another graph. What we are doing is we are changing the values. So we are putting domain as a range and range as a domain. That means what we are doing is this is x-axis and this is y-axis. So we are converting this or exchanging this axis. So this will become x-axis. I'm writing x-axis, but I'll write the value of y-axis, and this is y-axis, but I will write the value of x-axis. So in x-axis I have written over there as angle, and the value range will be on this axis. So it is different. This is 1, this is minus 1. Likewise, this is pi by 2 and this is pi by 2. So the graph can play like this. So whatever we are getting is sine inverse x. This is the graph of sine inverse x. Let us consider the second one, inverse of cos, inverse of the graph we will see, and we will see some values over there. The domain for cos x, f of x, we consider equal to cos x. So it has two values, that is first one is domain, another one is the range of a function. We are putting 0 to pi to make it bijection, or make the to get bijection. We are considering this one, and for cos it will work as a domain, this will work as a range. But cos inverse x, it will work as domain and this will work as range of function. Or better I write, cos inverse is a function from -1 to 1 with close bracket or close interval to 0 to pi, the close interval. We will see the graph of that. We'll see the graph of this cos inverse. Cos inverse can be defined like this. This is pi, this is pi by 2, and this is 0, this value, and this value. This is 1, this is -1. So it can be defined as, so this is 1 and this value is -1. This is pi by 2, this is pi, and this is 0. Obviously this is 0, this is minus pi by 2. So 0 to pi we are getting is cos inverse x. This is cos x. Coming to the next trigonometric function, that is tan inverse x. Tan inverse x, first of all we will consider f of x equal to tan x and for this we'll have that domain of a function and range of function. We will see the domain for 10x minus pi by 2 to pi by 2. We'll consider this, and the real number is the domain. So for tan inverse x, this will work as domain and this will work as range of function. So we can write tan inverse is a function tan inverse from r to minus pi by 2 to pi by 2. We will see the graph of tan inverse also. We'll draw over here. So these two lines are known as line at pi by 2, and this is minus pi by 2, and this is a real number. This is x-axis, this is y-axis, this is a function, graph of function 10x. So we'll have some more. What we are doing is, this is pi by 2 and the dotted line I am drawing, that is minus pi by 2. So what I have is from here to here, likewise it is going to infinite, and you can see here it is a tangent at pi by 2, definitely we know, and the function is increasing over here. Here also we are getting the increasing function. Tan inverse x is by default it is increasing function. Here it is we can see the decreasing function over here. Here also we are having the decreasing function. How to know? By looking the graph, how to come to know for increasing or decreasing. So from left to right, if I increase my number on x-axis, so function value of function is decreasing constantly. That's why it is decreasing function. Here from this point to this point, if I move, so I'm moving from here to here, so it is increasing. Upside is increasing, downside it is increasing, decreasing. Now coming to the next one, sec inverse x, the fourth one. Let us consider function f of x equal to sec x, secant x.